Hey YouTube, welcome back. Today we continue our course in system design fundamentals. Today we will talk about horizontal scaling. So before we talk about horizontal scaling, let's talk about what is a problem that we have that we need to use horizontal scaling to solve it. So let's just try to have this small system and client, and this small system. This client is connected with server, okay? And let's say that the server, our application, we were quite lucky. So our application was successful. So we have multiple clients trying to reach our server, okay? So all of them is trying to reach our server. And right now our server was quite overwhelmed with all of these requests. So what we should do to solve that? There is one way is to do some what we call vertical scaling, and this referred as a scale up, and this means the process of adding more power like CPU, RAM, or etc. Basically, we can add more resources to your servers. And it could work, like we can just increase the server capacity and it could work, but we have a quite small problem, two problem. The vertical scaling has a hard limit. It's impossible to add unlimited CPU and memory to a single server. We have some specific limit. And the other problem that we come up with this one is that vertical scaling does not have failover and redundancy. So if one server goes down, the website goes down with it completely. So if we have this one goes down, okay, the website was done and completely. We cannot solve that. So this where the horizontal scaling system come into place. So horizontal scaling, also known as a scale out, is a method of expanding systems. Just to go back here, expanding systems capacity and performance by adding more machines or nodes to a distributed system rather than increasing the power or capacity of existing individual machines. This approach involves distributing the workloads across multiple servers, each of which handles a portion of the overall load. Horizontal scaling is a fundamental concept in system design. So let's just try to see how this will work. So we'll add more machine, and instead of creating, we're adding more machines. So basically each client could connect. Of course, in real world, it doesn't, like, the client doesn't connect to the server directly. They need to have something we call load balancer in between. But for the case of the simplicity, we just assume that the client could connect to the server directly. So right now the client connect to the server directly and no problem at all. And right now, if we have more load, we can add more servers. If one of the servers went down, the client could connect with other server, no problem. It's not a big deal, and it will work well. And actually, we have a lot of benefits that comes from horizontal scaling. So let's just try to talk about some of it. So let's just have the first one we will talk about is that, as you can see from the design here, we increase the performance. Let me make this smaller. So we increase the performance, basically. Horizontal scaling allows system to handle higher volume. Like, we can add more clients and we add servers for them. So no problem with that. We can handle more volume of traffic and requests by distributing the workloads across multiple servers. And this can lead to improved response time and better overall system performance. Also, we improve the redundancy and the availability. So basically, adding more nodes enhance system redundancy. If one fails, the other can continue to operate, reducing the risk of downtime, data loss. This is especially important for critical applications and services. We can talk about the cost-effective scaling, because it's quite important to talk about this one. Basically, it can be more cost-effective to add smaller community hardware servers than to invest in high-end expensive hardware upgrades for single machine. Horizontal scaling allow organizations to scale incrementally incrementally as needed. Geographic distribution also, we can use it also in the geographic distribution. Also, it's a great in fault tolerance, like we improve the fault tolerance. And this will be the last one. Like web application, especially those with variable traffic patterns, benefit greatly from horizontal scaling. It ensures that the application can handle traffic spikes without performance degradation. So yeah, that's it for today's video, and that's it about horizontal scaling. And I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you guys in future problems.